Hey guys, welcome to today's Sunday contest. We'll be discussing problem number 3. Let's get started. So, basically, you are given an array, you're getting a permutation, right? And you can do two operations, either rotate by left, rotate one by left, or you can reverse the array. Okay, so the main idea is this is observation based problem, and we will start from reverse. So imagine that you have the array is already sorted and you want to reach the input state, right? So input state, we could do two operations, rotate by left or reverse. So in order to go from the sorted state to the input state, you can rotate by right, rotate one, rotate by one right, or you could reverse, right? So yeah, so we are just mirroring the operations just to get from your, we are just thinking backwards basically. Okay, so now the idea is to see what kind of arrays you can reach. So if you are given 1 2 3 4 5, then let's say we rotate by right, we rotate 2 by right, like you move 2 places to the right. So right rotation is like 2 times like this. So like the first one will give you 5 1 2 3 4, I think, right? And then the second one will give you like, I don't know, 4 yeah, 4 5 1 2 3, right? Yeah. And then let's say you reverse this array, let's say you reverse this. So now your array will look like 3 2 1 5 4. Okay, so the main trick and the main observation here is that you need to keep your eyes on this one, like where is this one going and how it is behaving. So after you did this right operation, like rotated by 2, what happened was your one landed here, but it's still, there's still a wraparound characteristic with this one. So it's like you are still able to sort this array in some way. So you are able to go to 1 2 3, and then all the way from 3 you're able to go to 4 and 5, right? So there is this wraparound behavior which is always preserved, yeah. And this observation you can only get after doing a lot of examples. Let me be very clear. So that's what I did, like this is my drawing when I was actually solving the problem, and that's when I figured out, yeah, this wraparound behavior does exist. And it's pretty easy to see after you're after playing around with it a little bit. So even after reverse, this wraparound behavior will just get shifted to the left. So here you're wrapping around from the right because you're going like 1 2 3, and then yeah, wrap around for 5. But here after reverse, it's going to the left, 1 2 3, and then wrap around for 5. Okay, so and let's do one more right rotation. Then what you'll get like 4 3 2 1 5, right? So the wraparound behavior is still preserved, it's still going to the left now instead of the right. And if you reverse it, if you reverse this array, you get like 5 1 2 3 4, right? So now the wraparound has mirrored, it goes to the right. So one observation here is your array will always has to wrap around either to left or right. Okay, and if your array doesn't wrap around, then there is no answer. I mean, you cannot sort it, right? So basically now going from 5 1 2 3 4 to your sorted array originally is very easy. You could just follow the same steps in reverse probably, right? Okay, so after you are done figuring out this wraparound observation, this is your star observation. Now you want to actually solve the problem, right? So there are two things now. So let's say you are given this array. Let's say you are wrapping around to the left, 5 1 2 3 4. Okay, let's say this is the array, and you want to make this 1 2 3 4 5. Okay, what can you do? You either rotate by left to the one, like rotate once by left to get 1 2 3 4 5 in one operation, pretty easy, right? Just left. and or what you can do is you can reverse the array. You can reverse the array. Reversing will give you 4 3 2 1 5. Okay, and then by reversing you change the wraparound characteristic. You flip the wraparound characteristic. Initially the wraparound characteristic was towards the right. By reversing you made it towards the left, because now you're going 1 2 3 4 5 1 2 3 4, and then you're wrapping around to 5. Earlier you used to do 1 2 3 4 and wrapping around to the 5, but it happened from the right. So we reverse the array, and now we do all left rotations, all left, to get one in place. Okay, so now it's just the index of this one. So after reverse, its index would become like, if you have an element like 1 is at I, then it would go at n minus I minus 1. So here in this case it is at 0 1 2 3 at the third position. So that means that you just do 3 rotations to the left, 1 2 and 3. So we need to do 3 left rotations. That's it, I think, right? 1 2 3 4 5 to get your like, oh okay. So after you do 3 left rotations, your array will look like this. You get 1 5, I don't know what you'll get, 1 5 4 3 2 maybe, right? And then you do one more rotation, one more left, to get your array in reverse, 5 4 3 2 1. Okay, and then you do a reverse operation to get 1 2 3 4 5. So this is another way to do it. Okay, this is another way to get your array. So either so the default rule here is that if your array wraps to the right, as we saw here, it's wrapping to the right, then what we can do is that there are two choices. You have two choices. Either, so your one is lying over here somewhere and it's wrapping to the right, so it's easy to like just rotate all the way to the left from the index. Let's say 1 is at I, so you can do I rotations to the left. So I rotations to the left, or you can reverse your array to make it wrap around to the right. So, or we can spend one operation reversing it. So then your array would, let's say, look like this, 1, and it's wrapping around to the left now, right, as we saw here in this case. And then after reversing, you have this one at n minus I minus 1 position, right? So you rotate left by n minus I minus 1. So what you get is, you get 1 and then like 2 3 4 5, like we got this, right? Yeah. And now we do one more left plus one reverse. So what you get is, you get 5 4 3 2 1. By doing one more left plus reverse, you get 1 2 3 4 5 again in the sorted array. So now if you count this path, you're doing how many operations? You're doing 1 plus n minus I minus 1 plus 2 because one more left plus one more reverse. So what is that? This number is n minus I plus 2. Okay, so it will be the minimum. Answer will be the minimum of these two, because you can do I or you can do n minus I plus 2. Let's take the minimum of I and n minus I plus 2. Okay, yeah. And similarly, we have to think of the case where the array was like originally wrapping to the left, wrap to left. Okay, yeah, I n minus I. Okay, so wrapping to the left. So like you have one and it's wrapping to the left like this. Okay, so for example you have the array like this, 1 2 3 4 5. Yeah, so what you can do is you can let's say you reverse this array, right, so that it wraps around to the right. um, or let's say let's do the simple thing first. Let's drag this one all the way to the end. Okay, yeah, you cannot do that, sorry. So what you can do here is let's try to, you know, I don't know, let's try to do what we did here, I guess, right? It's if it's wrapping to the right, we did a wrap to left by reversing it, right? So you spend one operation reversing it. So we are standing at this position with our index I over here, right? So we know that if we are standing at I here, then we just need to follow these sequence of steps. So what we need to do is we need to like we rotate left by this. So you get this array 1 5 4 3 2, and then you get one more left plus one more reverse. So 5 4 3 2 1, and then you get 1 2 3 4 5. So how many operations did we do? We did I operations to get one here. So I is 0 1 2, so 2 ops to get this plus 1 plus 1. So how many did you do? We did I operations plus 2, right? I plus 2 operations. And there is still another way you can do it. You can now wrap to the right by reversing it once, right? So now we are playing symmetry. So wrap to the right by one reverse operation, you get this array. You get 1, but now it is at n minus I minus 1, and now this guy is wrapping to the right. Okay, yeah. Yeah, and since it is wrapping to the right, what can you do? You can simply, you know, just do like I operations maybe. So your array now looks like, so earlier it was 3 2 1 5 4. You did a reverse, so you got 4 5 1 2 3. So this is wrapping to the left, now this is wrapping to the right, and now you just pull this guy all the way till the start. Okay, so you get n minus I minus 1 operations to do it, I guess, right? Yeah. Yeah, I think n minus I minus 1 operations to do it. So if you do 1 2 3 4 5 4 5 1 2 3, okay. Plus one reverse, right? Plus one reverse we did in order to wrap. So you get n minus I operations. So you take the minimum of these two now. Okay. And I think we can also explore the other case where since we wrap to the right, we can like, I don't know, we can also consider reversing it again and wrapping to the left, basically this branch, but then that would increase the number of operations, because why would you reverse it again? Like reversing it again would wrap to the left and you're stuck at the same problem. So yeah, these are the only two possible operations that you can do, I plus 2 and n minus I. Okay, yeah, so pretty fun problem. That's my, I mean, the code is pretty simple now. We just check if it is rotating, wrapping either towards the left or the right using these two blocks, right? If neither of them are happening, then -1. else if let's say OK1 is basically wrapping to the right, so it's minimum of I comma n minus I plus 2. Yeah, so this one, I comma n minus I plus 2. OGID is basically I, the original ID of the minimum index, right? And else it is n minus I and I plus 2. So yeah, n minus I and I plus 2. Okay, cool. That was the video. Thank you guys for watching. Bye.